And now we need to see how exactly the function would call, the program would call the function and use the received value. The function will return a value in most cases, and the main program should use the returned value. Now, let me remind you, in this, the assignment on 5.2 problems ask you to use functions that were written in the previous assignment, 5.1, section 5.1 functions. So these problems are asking you to use those functions to achieve something. Remember, you can rewrite the function in the program, but you must write the exact same function that was described in 5.1. Don't write a different version of it that would be more suitable for the needs. It's essential that you use exact same function to do these problems. All right. You don't need to copy the function again in this in this assignment on section 5.2, but if you choose to write it, that's fine, but it has to be the same function that you use. You do not rewrite a new version. All right, let's proceed to understand the function, calling a function. To call a function, simply use the name of the function. That's all you need to do. Just write the name of the function. And if the function is expecting data from the main, in other words, if the function has parameters inside the parentheses, that means those parameters are designed to receive values. So if there are two parameters, then you have to send two values to go into those parameters. If there are three parameters, you must send three numbers. So the number of things you send over to the function must match the number of things expected. So function call would look like this. The name of the function, in parentheses, values, we call them arguments, that would be passed on to the parameters the function has in the parentheses. So these arguments should be separated. They can be numbers or some variables that have the numbers. So anything can go here, but they have to be separated by commas. So let's see our example. Yeah, before the example, just remember the number of arguments must match the number of parameters found in the function header. So also the data type should match. If the data types don't match, then they will be converted. Conversion will happen. It's just like conversion happened in the assignments. Like if I write int x equal to 3.57, you know that 3.57 will be converted to int, which means only 3 will be stored. The same thing happens in the function call. So if the parameter is declared to be int and you're passing a float type number, the float type number will be converted to int. So conversions will happen during the assignment of your data to the
Uh,
parameter. Yeah.
so if the function header is int, and then the parameters, if we change the float, the whole thing will be int, right?
No, I'm not talking about not the function header. Function
Oh,
header int means you'll return int type value. So if, for example, if I say float uh, average, let's say this function finds average, and then I have int x comma int y. That means this function will expect two integer type numbers, and it will return one float type number. Understand?
oh, okay, okay.
So when you're calling this function in the main program, you would write main somewhere in the program. Let's say I'm using float a equal to 3.5, b equal to 2.1, and then I'm calling that function average. Average. Then I had to pass two numbers. I can put numbers in this parentheses, or I can put the a comma b. The only problem here is a and b are float, and x and y are ints. So what numbers will be actually stored in x and y? Anybody?
It will be just 3-2, right?
3 and 2. That's what you're getting in x and y. As long as that's acceptable, this is fine. If that's what you want to do, then
Um,
this is fine.
I have a quick
Yeah.
question. So does it always round down when it's being converted?
Not rounding down. It's remember, this is going back to chapter 1. Uh, when you convert, you you lose the fractional digits altogether.
Okay,
All right, no rounding.
just checking. Thank you.
Yeah, that was that's something we discussed in chapter 1. So conversion means the fractional part will be dropped, the integer part will be assigned. So average AB will be fine if that's what you want, if you just want to pass those integer parts. Otherwise, you had to change the average function to have float type variables for the x and y. X and y should be really float. Uh, okay, so let's understand how it is carried out. When the function call is executed, it will deviate immediately to the function and go there and do everything there is. So when this is executed, this average AB is executed, you will immediately go over here, jump over here, and copy these values. So you will be storing 3 and 2 in these variables. And then inside here, you have a local variable float average, and say, let's say av equal to x plus y over 2 is written here. And then you have a return app. Let's say that's how function average is written. Then the 3 and 2 have been stored in x and y now. So it proceeds to execute everything you have. X plus y over 2 is now 3 plus 2 over 2. And that's 5 over 2, 2.5. X and y are integers. So I need to divide by 2.0 to get the 2.5 correctly. So the value 2.5 will be now stored in the variable av, and then I'm returning the value of av. So it will return the 2.5. Okay, so if it returns 2.5, when you come back here, where is that 2.5? It is going to come back now. When the return is executed, it'll come back to the main. When it comes back to the main, it will come back to the same place. So now we have the value 2.5 back. Where is it? That value is carried by this whole thing. The call itself is going to bring back the value. So therefore, if I want to copy the result into another variable, I can do that. I can say C equal to this. And then I can proceed to do whatever I want to do with the C. Or if I just want to print the result found by the average, I can just say C out this, C out the average AB. So it'll call the average AB, find the value. When it comes back, this whole thing has the value and you're printing it. That's how the function call works.
Question. So, without on the main function, the body, you have float A equals to 3.5 and B. Can we remove that and place 3.5 inside the average, the parameters, like average 3.5, comma, 2.1?
You mean in the function header right up here?
No, 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 inside the main.
Oh, yeah.
Yeah, just you don't have to like state it and then call it. Can you
In
just?
other words, you're asking, can we send numbers instead of these
Oh
variables?
yeah, exactly.
Okay. Yes, a good question. Yes, we can actually send 3.5 comma 2.1 right here. Yes.
And we don't need to do the float A equals 3.5, right?
But in that case, we don't need that. Exactly. If
Got it. Okay.
Mhm. But usually in a program, the values you need to pass to the function are already there in variables. So you pass those variables. That's normally how it happens. But see, if I'm calling square root function to find the square root of 25, I can say sqrt 25. That is correct. Okay. The square root function is is one of the library functions. We'll be discussing that later. Um, And you can call function and any function and pass the number instead of a variable. Yes. All right, so let's proceed to yeah, I already explained it, so let's go through this one more time. If I have a main program that has cout square phi, where square is a function that'll square any number, then when the square phi is executed, it will deviate to the function. The function is written at the bottom of the main in this case. Normally, the best place to put the function is at the top. Before the main, you write the entire function. That's a better way. Then it'll come down here to the function and it'll copy the 5 into num, and then num time num was computed and it'll return that value. So now you're going back. When you go back, entire square 5 has the value 25. So you can see out that, or you can do whatever you want to do with it. You can use it within an expression, another expression like this. Let me go to the board and write something like, write a statement that will use the average. Something like W equal to X times average 3 comma 4 plus 5.5. So I have an expression in which average 3 comma 4 is used. So when this is seen, it'll immediately deviate to the function and carry out everything, bring back the value, and that value is what this is. And that will be now multiplied by X, and then 5.5 will be added to it. All those will be done. So you can use the function call within an expression, within some other expression anywhere. All right, moving on to prototypes. Now, like I said here, function should be written at the top. Because if you write the function at the top, then the compiler is always reading the entire file line by line from the top, right? It doesn't read from bottom. So therefore, if the function is at the top, the compiler will be reading that first, and therefore it will know the existence of the function when it sees the function call. When it sees this function call, it'll know this function was there at the top. If it is not there, then when it sees this, it wouldn't understand it. So if you know, it's only a machine reading it, right? So you need to make everything very clear. So if it doesn't know what this is at this point, then it's going to complain. So you're going to get error message if the function is not at the top. So therefore, if you do want to write the function at the bottom, then you need to tell before the main somewhere that I have a function called square, which will receive an integer and return an integer. So that would be this header, basically, this header without the name num. Only the variable name is not needed. So I can copy this and put that at the top right here. Put that there, and then eliminate the name. That is called the prototype. So if I want to put the function at the bottom, then I have to put this at the top. It tells the system, tells the compiler that I have a function called square, which will receive an integer and return an integer. All that is that right there. You don't put variable name in the prototype. And that is required if you put the function at the bottom. And if you put the function at the top, then this is not required. And that's what function prototype is. Basically, the function header without the parameters, without the name of the parameters. Yeah.
Question. So is this like a programmer like is this what they do like because it feels like the program is being squished, right? The main program, you have your prototype on the bottom and then the the name of the function on top. is just aesthetic reasons, or is there a purpose for this?
Uh, no, actually, if you just write the actual entire function at the top, you can have more than one function. So write all the functions at the top, then there is no need for prototype. It is a matter of preference. If a programmer wants to put the functions at the bottom and start out with the main, then you have to have prototypes at the top. Okay, so
Okay.
matter of taste, matter of preference. So if you don't care about where the functions are written, put them at the top, then there's no problem.
Yeah, I think I read better like that when the function's on top instead of
Right.
just doing
Reader will
bottom and
also,
top.
right. A reader will also read better. And so that is the preferred method. All right, moving on to example. So here's an example of a main program with the function written at the bottom. So main program is right here, and function is at the bottom. This function returns the square of any number received, and I need prototype at the top. So this function is using the square function to print print the squares of all the numbers entered by the user. So user is entering numbers one after the other, and he will enter a 0 as sentinel. So while val is not 0, we are outing the square of the number entered and then going on to the next number. It's just a simple example that uses the function square. So this program uses a function called square to print the squares of all the numbers entered by the user. That's what it does. If you put the function at the top like this, then write the main, then you don't need prototype. Okay, I already explained it using example on the board that you can pass numbers. The numbers will be actually copied. And when the data types don't match, the numbers will be converted to match the data type. So here is a program that will use two functions. So let's read the entire example. It says write a program that uses functions to write the title prime numbers and underline with asterisk, and then it will write prime integers between 1 and 20 underneath it. It'll write all the prime numbers between 1 and 20. Okay, so I have a function called void write title that'll write the title, prime numbers, and underline it. And then I have another function on the next page that will determine whether a received number is a prime or not. So it's written, function is called isPrime, and it will receive a number and determine whether it's a prime or not. So let's go through this function first. It will receive a value in the variable val, and it will determine whether this value is a prime or not. To decide whether it's a prime or not, you need testing numbers go from 2 all the way to less than val. Actually, val divided by 2 will be better, halfway. And increment by 1. For all of those test numbers, you test to see if it divides. If the test number divides it, then you can return 0. You know that the number is not prime. So notice that here, when I write this program as a function, I don't need to use the flag. Remember, if you remember the way we wrote it before, we had to use a flag that will signal that the divisor has been found. And then we use that flag to determine whether number is prime or not. If the divisor was found, then it's not prime. Otherwise, it is prime. But when you're writing it as a function, you have the advantage of using return statement. So this function is going to return, it's supposed to return a 0 if the number received is not prime, and it's supposed to return a 1 if it is prime. You can write it to return true or false if you like, but this particular function is written to return 0 or 1. So if val modulus divider is a 0, that means we found a divisor. That means it's not prime. Immediately I can return 0. So go back to the main with the 0 as answer. And then what is this return one doing? Here's why. The divider starts at 2 and goes all the way to val over 2. It should be val over 2 really. And because no number bigger than val over 2 can divide it evenly. Okay, so it will go all the way to val over 2. And if it doesn't find any divisor, then this return 0 will never be executed. Only then it will go out of the loop. If it ever finds a divisor, this return 0 will execute and it will return to the main. It will never execute the return 1. But if no divisor was found, after checking all the numbers from 2 to val over 2, if no divisor was ever found, then return 0 will never execute. So then it will come down to a statement that is after the loop. This statement is after the loop. So this will be executed now. So when will this be executed? Only when there was no divisor found. If any divisor was found, then return 0 would have been executed. So the function is very simple, very small compared to the original function program we wrote in chapter 4. We wrote that program that determines whether a number is prime or not. That was much longer than this. So because of this return statement, we are able to shorten the program. If a divisor is found, then return 0. If no device is found, then return 1. And it's more elegant and very simple. Okay, so let's go to the main program now. The main program has 2 prototypes because 2 functions are at the bottom. Notice the prototype for the second one. Int is prime, int. There's no parameter. It's just the header of the function without the names. That's what prototype is. All right, in the main program, oh, I think I erased the word main accidentally. Okay, in the main program, num is an integer variable. I'm calling write title. See, write title is not going to return anything. I just have to call it to get the title written on the output screen. So that's what this is doing. This function is not returning anything. That's why I just make the call and move on. For num equal to 2 to 20, we're supposed to find all the primes in the range 2 to 20. So that's why this loop says for num going from 2 to 20, call is prime, pass num. If is prime num is 1, that means it's prime. In that case, write it. So notice that I'm using the is prime call within the condition of the loop of the if statement. So I'm calling is prime num, and if it returns a 1, I'm comparing the returned value to 1. If it returns a 1, then see out num. Otherwise, we are ignoring that number and moving on with the loop. Again, I messed up something. Okay, so moving on with the loop. It's a for loop. So when num is 2, I'm calling is prime 2. If it is prime, I'm writing it. Otherwise, num changes to 3. And then is prime 3. Is prime is called with the 3. And if is prime returns a 1, then the number is written. Otherwise, it's ignored and the number goes up. So this will find all the primes in the range 2 to 20 and write them. So this is a program that calls two different functions. It calls write title just to get the title written, and then uses this prime to determine whether each number is a prime or not. Okay, so the output from this program are these. These are the prime numbers in the range 2 to 20. All right, so let me see. It says write a function called max that receives 3 numbers and returns the largest one. Then write main program that requests and receives 3 numbers from the user All right, so your function is going to find largest of the three numbers. Now, I already explained, you already learned the technique of finding largest of three numbers, 3 or 4 or 5. If it is finite number of things, then we have a method. You learned that before, you will test it on that. So go ahead and write it as a function now. It's going to receive three numbers and it will return the largest. And then write a main program that will get three numbers from user and it will it'll print the largest of those numbers. Okay, let me see who can write it. Remember, this is not difficult. This is not supposed to be difficult for you. It's very simple, but we have to see it written in the form of function and function call. That's why you're writing it now again. You wrote this before. All right, go ahead and write your program. I'll leave this on the screen in case you want to read it. In fact, if you have written the function, I want to see that. Just write the function first. Assume those numbers will be float type numbers. All of you should try it. You know, if you just sit there without trying, you'll never learn. Please try to write whatever you can. It's okay to be wrong. All right, I have a couple of questions here. ABC. Two things, Sam. One is the name of the function and the variable name inside should not match. You need to make a different name, variable name. And
Oh yeah, I made it val. That's what I meant to the.
Okay. Then
Yeah, I meant it to be the val float that I created. That was
okay.
just a brain fart.
Shouldn't you copy the first data into the maximum variable? Val is your variable, then you should copy the first data into it first, right?
Got it. Got it.
All right. Yeah, let me remind something to all of you. In this last project, it tells you to use a very large number as the initial value of the minimum variable, min variable, and then compare the actual data. That idea is not going to be good for general programming. In that particular problem, that was okay because the stock prices are limited to be greater than 0 and less than 1,000 normally. So that idea was okay there. But normally, to find maximum, you start your variable, the max, at one of the values. Start it at one of the values and compare it to the remaining values. Any other method is not acceptable. Okay, so you need to make some corrections in your program. So, right, I'm looking at ANISA solution, max equal to A if B. Did you mean to say if B greater than max? You're saying B less than max.
Yes, I am. Sorry.
Yeah, and also the name max should be changed to large, or just call it M if you like, but it shouldn't be same as the name of the function.
Got it.
Okay, looking at Christopher's test, and then, well, okay, same kind of mistake. The test has to begin at one of the numbers. So you can start by saying test equal to val 1. You didn't say that. That's for Christopher. Okay, so test has to have a value to begin with. When you compare
Right.
to test doesn't have a value.
Right. Okay.
Okay, so test equal to val, that's where val 1 would be a good idea at the top. All right, so far 3 students made attempt. Oh, there's one from Alexander, I didn't see that. Max equal to A, max greater than B. You meant to say B greater than max, Alexander?
If max is greater than B, yes.
B greater than max.
Yes.
Okay. Similarly, C greater than max.
Yep.
But don't use the max. Change it to M if you like, but because where the function name is max.
Yes. Okay. Thank you.
All right, that's 4 students. Okay, very good. There's 2 more. I'm looking at Terence's solution, float ABC and largest equal to A and return largest. Right, very good. You got it. Terence got it perfectly right. I'm looking at Anisa's second version, large equal to A, if B greater than large equal to B. Right, now you have it. Very good.
Thank you.
I don't see anybody else. I have 16 more students in this class. All right, it looks like nothing else is coming. So let me proceed to explain that solution here. The name of the function is going to be max. So float max, and it'll receive float A, float B, float C. So these are parameters to receive 3 numbers. So inside, I can declare a variable float type called M. You should use meaningful names, but I'm using something simple. And copy A into it. And then if B is greater than M equal to B. This is the technique we learned for finding largest. And this is the same technique you should have used in your project. And then if C is greater than M, then M equal to B, C. After these statements are executed, M has the largest because we have already compared all of them. And this is the best technique because it uses minimum comparisons to achieve the task. Return M. M has the answer. Now, the program also asks you to write a main that will get 3 numbers. So I'll declare float x, y, z. Now, these x, y, z are going to be passed on to the function max. Can I call them ABC? Same names as ABC here? Yes, but I would recommend using different names to avoid any confusion, because those ABC and these ABC will be totally different. What you declare here in the main, any variable declared here will not be recognized in the function, and any variable used in the function will not be recognized here. They are independent programs. So if you use different names, it'll be much easier for you to avoid confusion. Otherwise, confusion can happen. So I need to get 3 numbers from the user. So ask user to enter numbers and cin x, y, z. Now I'm supposed to find the largest of these numbers and write that on the screen. I can write a cout statement that says cout max x, comma y, comma z. So this will call max and it will find the maximum. It'll bring it back and it'll cout it on the screen. All right.
Got it.
Okay. I'm skipping the next exercise and moving on. All right, some facts. I already explained most of these things. The variable types, the parameters, the types of the parameters and the types of the values you're passing must match, otherwise they'll be converted. Variables declared in the function are not recognized in the main. Variable declared in the main are not recognized in the function. The only means of communication between main and the function are the parameters. The x is passed into A, copied into A, y is copied into B, z is copied into Z, C, in that order. It'll copy everything in that order. So you should have the numbers in the right order if you need to have them in any order. And also, if there are 3 parameters in the function, 3 values must be passed, otherwise error. So those are the rules I'm explaining here. The variables, never expect a variable in the main to be recognized in the function, and vice versa. All right. Yeah, here I'm using an example to illustrate that variables in the 2 different things, the function and the main, are not recognized. So I'm receiving a k function. This main program calls the function square and passes a k. K has a 5. And so that 5 is copied into num here. So num now has a 5. And so here num changes to num times num goes into num. So num changes to 25. And you're returning num. So because you're returning num, the square k is now 25. Now the fact that k was copied into num means it was only a one-way copying. The num doesn't get back to k. The copying of k into num is just one-way copying only. So the value you need to return has to be returned. And if you have a variable num here, and if that is being used for some other purpose, like this, int num equal to, oops, let's say 12, something like that. And if you see out the num here, what will be printed?
I think 25 and 12, right? Will be separated.
Yes. The
Okay.
variable num here in the function has 25. the variable num in the main has 12. So when you have a cout num in the main, that's going to print the 12 that you have in this local variable. This num and the num here are two different nums. They're not connected. They're not related in any way. So those are the facts that I explained there. All right, going on to, yeah, it's the same fact I'm explaining. If you have same variable names in different functions, they should not be mixed up. You know, they are all local within those functions. So whatever variable declared here is local here. This W is not recognized in the main or the other function. And the variable M here has J modulus K. That M and this M here in the main should not be mixed up. They are local. They're only recognized within those. Other than that, this example doesn't serve any purpose. We have already seen enough examples. So that finishes that section. You need to do the assignments on that, and we are proceeding to 5.3, function libraries. There are libraries, so as you can see, the function is a separate unit. So that means for difficult tasks, functions can be written and collected somewhere, and you can use them in your programs. Such libraries have been created. Large libraries of functions have been created for difficult tasks, such as square root. Now, square root simply looks like, you know, square root of any number, like 9.7. How do you find square root of 9.7? Think about it. You use calculator and other things. They're all programmed to follow a certain technique that is that you would learn in an advanced math to carry out this kind of expression, square root, by using what is called power series. That's a topic in calculus 3, so you're not ready to understand that. So using series method, you can find these difficult things, such as square root, and trigonometric values, sine x and cosine x, and all those can be found by using power series. And that's what these functions are doing, or even calculator is using those techniques to find them. So when you punch in a square root, it's giving you a number, doesn't mean it's easy. So these are difficult. You know, your program has to use a power series and find the accurate answer, and it's a difficult process. And so functions have been written to find these, to find difficult things such as square root. And so we can use those library functions in our program to get things done. And those libraries are the ones we're going to discuss. All the functions, we're not going to discuss all the functions. Each library has, you know, several hundred functions, and we don't have time to discuss all that. If you become a professional programmer, you will end up learning most of those. But for now, in this course, there are certain functions we need to be able to use, and we're going to discuss only those. So here are some functions in the library called math library. Math library, I'll show you how to, yeah, I'll go back to the previous page. Math library has some mathematical functions useful in our programs, and so it is available as a collection of many functions, and anytime you want to use it, you need to pound include it. See, look at the board. The function is written right at the top here. The function I needed to use is written here. If I instead of this, if I pound include, then all those functions are going to be included in my main, at the top of the main. So all the functions in the library will be basically like copied to your main. It's as good as that. So you can just call the function within the main if you pound include the library. So pound include math.h, that's what you need to write if you're going to use math library functions. And after that, you can call any of those functions in your main. That's all you need. Just by writing that, you're bringing all of those functions to the top of your main program. So here are some functions, and these functions you need to remember what they do. Fabs will find the absolute value. The F stands for float apps. This will find absolute value of a floating point number. Sale will find integer greater than or equal to the number n. You're passing an n to it, it'll find the smallest integer bigger than this number. So if you pass like 3.5, it'll give you 4. It's not rounding it, it's giving you next integer, the integer next to this number. Floor gives you integers smaller than this, so closest integer below. Again, it's not rounding it for you. So sale will give you integer higher, floor will give you integer lower. So the names, if you associate the names, the seal stands for ceiling above, floor stands for floor below. So if you match the meaning, then you will understand what is what. Exp function finds e to the power, exponent, e to the power. Log finds natural log. So it's actually ln. In math, we write ln, natural log. That's what log is. Log 10 is the one that finds common logarithm with the base 10. Now, very often students mix up these things, so keep that straight. Log is natural log. Log 10 is common log with the base 10. Function pow finds power of any power. So now we can find power like 5 to the power, things like, we couldn't do this before, 5 to the power 25. Earlier we had to write 5 times 5 times 5 to get 5 cubed. Now we have power function, but you should use only for large powers like this. So, because this is a big deal. Calling that power function is a big deal. Power function uses a advanced technique. You don't want that advanced technique, which will slow down the program to find 5 squared or 5 cubed. Only for large powers, you should bring that in. So m to the power n will be found and returned to you if you call function pow and pass m and n. M is the base, n is the exponent. And like I said, use it only for the large powers, not for squares and cubes. SQRT is the square root function. It'll find square root of n and return it. And that's the one I asked you to use in the last project. Sine function will find the trigonometric function, sine of any angle. Cosine will find cosine of any angle. Similarly, there is tangent, cotangent, cosecant, all those are there. But these functions I have listed here, you will run into them in your homework and test and everywhere. So you need to remember what these functions do. These are the basic important functions, and that's why I listed these only here to let you know that these are the ones you need to know in this course. So that's the math library. And there is IO manip library. IO manip stands for input-output manipulation. These functions, the functions in this library, allow you to manipulate your output and design your output in any way you want. In the past, you couldn't control your output. If the output has 15 fractional digits, it's going to give you 15 fractional digits. You couldn't say, I only want 4 digits. Now you can do that with these library functions. So these are used in the C in, C out statements. Now, we are not going to go over any manipulation of the input. We're going to go over manipulating output. That's more important. So to manipulate output, you can use functions in this library. If you're using that library, you need to throw this in at the top. wherever you have all the pound includes, you need to write this pound include iomanip.h. Okay, so here are the functions. SETW stands for set width. Now these functions will be called within the cout statement. I'll show you example in a minute. So set width and then n. If you call set width and pass an n, that means you're setting a width for the output. So you're saying my output should be limited to this width. Width is going to be number of digits, basically, number of spots allocated for the output. So if you throw in a number 10 for n and call this set width n, pass the number n, pass 10 to this function, that means the next item you're writing should be limited to 5 spots on the screen, 10 spots, I mean. That's what that means. You're going to see example in a minute. Set precision means you're telling the system how many fractional digits you want, how many decimal digits. So if you say set precision 4, that means you're saying I need 4 decimal digits. So this number will be rounded. Now here we are, a way to get the number rounded when it is writing output. But this is only good for writing output. If you need to get the number rounded for some other purpose within the program, this cannot do. This is only for output. So when you're printing it, you can say, I want the number rounded to 4 digits. This will do it. Set iOS flags. You pass a flag, and the flag can be iOS : left, which means left align all my output. iOS : right means right align all the output. You'll see in a minute what that does. Fixed means you want to have the fixed decimal format, which means the usual number format, like 5.6791, that format, because sometimes the system converts your number to scientific format if the number is too big or too small, and you're forcing it not to do that. When you say iOS : fixed, you're saying I want the digits written, not the exponents. I don't want the scientific form. That's what you mean. If the flag is iOS : scientific, that means you're asking for scientific format of the output. Flag iOS : show point means show the decimal point, because sometimes if there are no digits behind decimal point, it doesn't show decimal point. So you're saying I need decimal point even if there are no digits behind it. All right, those are the flags. So this will be also written within a cout statement, and you had to put some flag. The flag will be one of these: iOS : fixed, iOS : right. So this feature is very uncommonly used, but the first two, set width and set precision, are very commonly used. Anyway, we're going to see example. So here is the first example. While m less than or equal to 5,000, multiply m by 10 and write within set width m. That means set width 5m means within 5 spaces, write the m. So the first number is 5. First number is 50, actually. I meant to have this one, this below that. I can't believe I had the mistake. Okay, that's what I meant to have. So if you have it that way, the first output will be 5 and then 10, 500, 5 and then 50, 500, 5,000. Those are the numbers. All right, so the set width, what it does is it writes all those numbers using 5 spots. So that's the point I'm making. So because you're using, now if you didn't use set width, this 5 here would have appeared at the left side. Because of the set width, it's written at the last entry of the 5 spots. There are 5 spots used here. let's again highlight that. Okay, 5 spaces used here. The last space is where the 5 is. And then here, 5 spaces are used. The last 2 spaces are used to write the 50. And therefore, the numbers are lined up on the right as a result. So normally they will be lined up on the left if you don't control it, if you don't do anything. That's the difference. Set precision 3 means round the number to 3 fractional digits. So for example, the result of this division A over B will be 3.143142. As you can see, this is the actual number. And when I see out it with the set precision 3, I'm rounding it to 3 decimal digits, and I get this number, rounded number. And here I'm using set width 5 and set precision 2. You can combine them, one after the other. Then I'm rounding the number to 2 decimal digits and using 5 spaces to write it. And I'm using 5 spaces to write it, so I have 1 blank at the front. Now remember, when you allocate 5 spaces, one of the space is for the decimal point. So this number requires 4 spaces, 3.14, 4 spaces. And so there's 1 space left at the front because you allocated 5 spaces. Okay, so that's how they work. And we'll stop here because we are out of time. There is one more library to discuss, and we'll finish this section in the next class.